Alright, good morning and welcome to mathsatoka online class. In today's video, we'll be talking about multiplication of matrix. Okay, now for any matrix A and B to multiply, okay, for any matrix A and B to multiply, okay, now unlike in addition and subtraction, that the dimension must be the same, but in multiplication, okay, the dimension of the row should be equal to the dimension of the column. That is when you can say that A can multiply B. Okay, so the number of elements in the row must be equal to the number of elements in the column before A and B can multiply. So you can write that for A and B to multiply, the number of entries, the number of elements, or do I call it elements or entries of the row of A the number of entries of row of the row of A must be equal to the number of entries of the column of B. The number of entries of the column of B. So let's take an example to that. If you have that A is equal to 1, 2, 3, 4 and B is equal to 1, minus 1, 2, 0, 3 and 5. So they say we should find A multiplied by B. Okay, find AB, BA. So let us find the solution. We are having that AB is what? Is 1, 2, 3 and 4 multiplying by 1, minus 1, 2, 0, 3 and 5. Okay, now in the multiplication they form 7 like this type of 7. Okay, so that is the row will come and meet the column. Okay, the row will meet the column, the row will come and multiply the column. So what do I have now? For this side I'm going to have 1 times 1, then this time this. Okay, 1 times 1, so I'm going to have 1 times 1 plus 2 times 0. Okay, that is for this side. The same thing will happen here again. The row again come and meet this side. I'm going to have 1 times minus 1 plus 2 times 3. Okay, the same thing will happen the other side again. 1 times 2 and 2 times 5. Okay, 1 times 2 and 2 times 5. Because of space, let me do it straight. So this is equal to the row meeting the column. 1 times 1, 1 plus 2 times 0, 0. Now the next one, this side will come and meet this side. 1 times minus 1, minus 1, 2 times 3. You have what? 6. The same thing here. 1 times 2 is 2. 2 times 5 is 10. Okay, so the same thing. I'm done with the first row. Let me start with the second row of A. So this will times this. 3 times 1, 3 plus 4 times 0, 0. 3 times minus 1, minus 3. 4 times 3, 12. 3 times 2, 6. 4 times 5, 20. So what do you have now? The answer finally becomes 1, 5, 12, 3, 9, and 26. Okay, as simple as that. So that is that. But let's check if B cross A is possible. B cross A is possible. You know, I didn't tell you that in addition of matrix, that they are closed. What do I mean by closed? A plus B must be equal to B plus A. Okay, but a multiplication is not so. A multiplication is not so. A plus B, B or A times B is not the same thing as B times A in matrix. So let us check that. Let us check that. BA is what? B first, which is 1 minus 1, 2, 0, 3, and 5. Then times 1, 2, 3, 4. Now, if you look at that, the number of entries in the row are 3, and the number of entries in the column here is just 2. Okay, and it is not possible because this will times this will times this, and this one don't have anybody to times. So therefore, BA is not possible. Okay, so BA is not possible at all. So let's use a bigger matrix for us to really understand it very well. So I have that A is equal to 6, 0, 1, 3 minus 2, 4, 5, 7, 0, 1 minus 3 minus 2, and B is equal to 3, 4, 1, 2, 0, minus 2, 0, minus 2, 0, 2, 1, 3. 4 minus 1, 5, 3, and 6. Okay, so the question answered, find A, B. That is I said find B transpose A. I said find B squared. Okay, solution. Now first of all, let's find AB. AB is simply, or let's do it direct, this into this. First of all, 1, 2, 3, 1, 2, 3, they can work. Okay, so let's start from the first one. 6 times 3 is 18. 0 times minus 2 is 0. 1 times 4 is 4. I'm done with this one. Let's go to the next one again. 6 times 4 is 24. 0 times 0 is 0. 1 times minus 1 is minus 1. So it cannot enter here. So follow the same process. This one will times this one. This one will times this one. This one will times this one. Then you will now continue from here again. 3 times like that again. 7 like this. So 3 times 3, 9. Minus 2 times minus 2 plus 4. 4 times 4, 16. Okay, then go to the other one again. 3 times 4, 12, plus minus 2 times 0, okay, is 0. Then 4 times minus 1 is minus 4. Okay, I have the same thing. Then continue and finish it up. Then this one now, let's do something again. This one to here. 1 times 3 is 3. Minus 3, sorry, I've not done 7. I've not done for the rule of 5. 5 times 3, 15. 7 times minus 2 minus 14. 0 times 4 is 0. Okay, the same here, move this way again. They go in 7 shape. 5 times 4 20 plus 7 times 0 0 plus 0 times minus 1 0. Okay, so the last one now, 1 times 3 is 3, minus 3 times minus 2 is 6, minus 2 times this is what? Minus 8. So this one will still move the other way again. 1 times 4 is 4, minus 3 times 0 is 0, minus 2 times minus 1 is plus 2. So you have to complete it. Okay, so your answer now become AB is equal to everything here will give me I think 22. Here will give me 29. Here will give me 1, and then finally here will give me this is 9 minus this is 1 again. Okay, so here will now give me 23. Here will give me I think 18. Here will give me 20, and here will give me 8. Okay, so complete your own to have the complete matrix. So that is that. Now the next one said B transpose A, B transpose times A. Okay, B transpose. Now B transpose times A is what? The transpose means carry this one, stand it. Carry this one, stand it. Carry the other one, stand it. So if I carry the row now, I'll stand it to be 3, 4, 1, 2, 0. Carry the other one, stand it. Minus 2, 0, 2, 1, and 3. Carry the last one, stand it. 4 minus 1, 5, 3, and 6. Okay? Then you are now multiplying it with what? 6, 0, 1. 3 minus 2, 4. 5, 7, 0. 1 minus 3 minus 2. Okay, so let's check if it is possible. We are using the rule here to multiply the column here. 1, 2, 3. 1, 2, 3, 4. It's not possible because this will times this, this will times this, and this will times this. What about this? So therefore, B transpose times A is not possible. Okay, so the last one said B squared. That is B times B again. Okay, B squared simply means B times B. B squared means B times itself. Look at B. That is 3, 4, 1, 2, 0. Minus 2, 0, 1, 2, 3. And 4 minus 1, 5, 3, 6. Multiplying by the same thing. 3, 4, 1, 2, 0. Minus 2, 0, 1, 2, 3. 4 minus 1, 5, 3, and 6. So let's check if it's possible. The rule here is 4. Multiplying the column here 3 is not possible. 3 times 3, 4 times this, 2 times it. What about 0? So it's not possible. So therefore, B squared is not possible. Okay? So for this particular one, but there are some cases where the squared is possible. But for this particular one, the squared is not possible. So that is that about multiplication of what is it called? Matrix. Okay, that is that about multiplication of matrix. So I think you have known how to get the transpose of a matrix. So the next one we'll look at is the trace of a matrix. The trace of a matrix. Now the trace of a matrix is just the addition of all the diagonals of that matrix. So before you can get the trace of any matrix, that matrix must be a square matrix. Okay, it must be a square matrix before we can be able to find the matrix. So look at what I mean by that. Example. Okay, if you have A is equal to matrix 1, 6, 2, 4, for instance, B is equal to matrix minus 362 405 217. Okay, matrix C is equal to 143056. So we have to find the trace of this. Find the trace of this. Okay. So find the trace of this. For us to find the trace of this, what do we do? Okay, they say calculate the trace of a comma b comma b squared comma c. Okay. Or let me say a, b and c, as simple as that. B squared means this times itself, then you can now find the trace. Now if you look at a, okay, the trace of a is a square matrix, so we have the diagonal. So let's just add it. It's what? 1 plus 4, so the trace is just 5. For B, look at that. It's a square matrix 3 by 3, so it has a diagonal. So what do we have now? The trace of B is simply minus 3 plus 0 plus 7, which will give you 4. Okay. For C, trace of C does not exist. Why? Because you cannot even get a diagonal. It's not a square matrix. So the trace of C does not exist. So the trace of C does not exist. Why? Because it is what? It is what is it called? Why? Because it is not a square matrix. So let's go to determinant of a matrix. We have gotten multiplication and square matrix. So let's talk about determinant of a matrix. I think that should be in another video. Okay, that should be in another video. Thank you very much for watching.